Chapter 30 Physics Theory Video 1 Medical Imaging. So this is a new lesson, but there are some theories that you would have that you have learned earlier. So the application of the different kind of rays, the ultraviolet frequencies and electromagnetic radiation, etc., is what we actually refer to in this medical imaging. So X-rays, you know that it was discovered by Wilhelm Röntgen. Then it is a form of electromagnetic radiation. So these are details that you know. They belong to the short wavelength, high frequency end of the electromagnetic spectrum. That is something that you need to remember, and that goes beyond ultraviolet radiation. Then X-rays have a wavelength ranging from 10 to the power minus 8 to 10 to the power minus 13, and this is something you need to remember, and are effectively the same as gamma rays. The only difference is the way they are produced. X-rays are produced when fast moving electrons are rapidly decelerated. So that means it strikes something and that is rapidly decelerated. As a result, X-rays are produced. When the electrons slow down, their kinetic energy is transformed to photons of electromagnetic radiation. So then gamma rays are produced by radioactive decay. So the alpha beta emission, following that, a gamma photon is usually emitted by the decaying nucleus. That is something that we have learned earlier. So this is the spectrum of electromagnetic the wavelengths. Radio waves have the highest wavelength, as you can see here. Then going beyond that, when to the left, the wavelengths decrease, as you can see. Radio waves, microwaves, infrared, then visible light and ultraviolet rays are there. Beyond ultraviolet rays, you have the X-rays and the gamma rays. So the region is something that you need to remember. So then they can, with just like all the other electromagnetic radiation, X-rays can be thought of either as waves or as photons or particles. Then X-rays travel in straight lines through a uniform medium. That is another factor that we need to know. So when you the purpose of X-ray is quite obvious. So when X-rays pass through a patient's body, the X-rays X-rays pass through the soft tissues without any issue, but when it passes through the skeletons, there is an area which will not be seen. So that will actually come out as an image. So we can easily see how the bones are structured inside the body. Now, in earlier, that is even now in Sri Lanka, so these X-rays are captured on photographic film. Now they are generally taken electronically, so they can be transferred through internet or just email to someone without having the option of taking it onto a plastic card. So this is a pelvic joint that is shown. So an X-ray would be made up of two electrodes. The tube is evacuated, and there is a cathode and an anode. The cathode is the heated filament, then which which produces the electron beam. Then the anode is a rotating anode. It's a positive, obviously anode is positive. It is made up of something, some hard metal such as tungsten. So that is the target metal onto which these um, electrons are bombarded. So then there would be an external power supply as shown in this figure 30.4 that produces voltages typically between 50 to 200 kilovolts. So that is a very high voltage is provided. So that produces an accelerated beam of electrons that jumps across the gap between the cathode and the anode. Then the kinetic energy of the electrons that arrive at the anode is going to be 200 kilo electron volts. When they strike the anode at high speed, they actually lose the kinetic energy, and that results, now they are rapidly decelerating, as you can remember from what I said earlier, and that produces X-ray photons. So they go in all directions. Now one part is there, that part will actually allow this to go out, and that will emerge into the space outside of the tube, and this will actually this will be there, this will go through the patient's body. It will go through the patient's body, and it can be seen, observed, onto a the whatever that comes out of the other side would be taken onto a photographic film, or it would be digitally observed. So then this X-ray, the width of this X-ray beam can be controlled depending on how much, what kind of an area is going to be X-rayed. So that produces, this controlling effect produces a parallel beam of X-rays called collimated beam. Now the inside of the walls are thick enough not to allow the X-rays to go through. So only you have to remember something, only a small amount of about 1% of the kinetic energy of these electrons is usually converted to X-rays. All the others will actually heat up the anode. That energy heats up the anode. So that is the reason why it rotates, because now when it is rotating, it can actually provide a newer surface, a newer cooler surface for the energy to for these electrons to come and bombard on it. So that is something that you need to understand. Then also there are cooling systems on the anode to remove these extreme amounts of heat that can get built up on it. Then when an electron come and collide, or come and bombard on an anode, usually what happens is this electron will get attracted towards the nucleus of this anode, the nucleus which is positively charged. Then this attraction results in the electron changing its speed as well as the direction, and it decelerates. This deceleration, or any decelerating charge particle, will lose energy by electromagnetic radiation. So kinetic energy has to be lost, has to be given away, because it does not disappear simply. So this is what results in a single X-ray photon. Some or else usually several photons. Then remember that in the earlier situations we spoke about a single electron. Don't confuse that with this. In X-rays, they are usually that will produce several photons when an electron come and bombard itself onto a hard metal surface. The electron will interact with many more nuclei and until all of its energy is lost and it comes to a halt. So the energy that is the energy E gained by electron when it is accelerated through the potential difference of V between the cathode and anode is given by E equals capital E equals simple E V simple E capital V. So that is the maximum amount of energy that an X-ray photon can have. As a result, we can obtain the maximum frequency, X-ray maximum frequency that can be obtained by this photon can be calculated using E equals HF. So as a result, F max is going to be EV upon H. So this is the equation that you need to develop. Let's write down a note before moving on to the questions. Write down X-rays belong to electromagnetic radiation belonging to the short wavelength high frequency end of the spectrum. Their wavelengths range from 10 to the power minus 8 to 10 to the power minus 13 meters. The same as gamma rays, but are different by the way they are produced. Put a star and write down X-rays are produced when fast moving electrons are rapidly decelerated, which emits its kinetic energy as photons of electromagnetic radiation. Then gamma rays, put a next star and write down gamma rays are produced by radioactive decay. Then write down X-ray tube is made up of a cathode that is connected to a high voltage which produces accelerated electrons. The anode is usually a rotating anode, within brackets write, to prevent heat from getting built up, close brackets. Which is made of hard metals such as tungsten. Please draw this 30.4, you would understand it better. When these electrons that passes through the gap between cathode and anode collide with the anode at high speed, they lose some of their kinetic energy as X-ray photons. Which spreads in every direction. There is a window that allows these X-ray photons to pass into the outside. and by controlling the width of the X-ray beam, a parallel sided beam called collimated beam is produced, which can be used for medical purposes. When an electron strikes the anode, it will be attracted by a nucleus, and as a result, electron changes speed as well as direction while eliminating its energy as photons. The energy gained by, leave a line and write, the energy gained by an electron when it is accelerated through a potential difference of V between the cathode and anode is given by E equals capital E equals simple E capital V. Which is going to be the maximum energy that an X-ray photon can have. So as a result, maximum X-ray frequency can be calculated using the formula E equals HF. Therefore, F maximum equals EV. Instead of energy, we put EV divided by H, simple E capital V divided by H. I hope you understood. If you did understand, please do question number 1 and 2. If you didn't understand, please ask me questions.